So now that we've plotted this pathway using parametric equations, t equals 0, t equals 1, t equals 2, t equals 3 perhaps, how can we describe the path itself in terms of x and y? In other words, for this particular path, we would be looking for something like y equals negative x plus 1, y-intercept of 1, slope of negative 1, the familiar slope-intercept form. You notice that t is not in here at all. And so we can actually do this with parametric equations, not just plot the path, but then also describe the path itself in terms of just x and y. And we call that eliminating the parameter. So let's review the process for that first, and then we'll do some examples and come back to the process. To eliminate the parameter, what we're going to do first is to solve either of the equations for t. It doesn't matter which one, we just want t equals something. And this something is going to be something with only x or something with only y in it. And then what we're going to do is to take this expression here and we're going to plug it into the other equation in place of t. And this actually forms what's called a composite function, if you remember that maybe from the beginning of the year. So we'll have a function of a function. And so now the equation from this step is now the relationship between x and y without t. So let's see how that works in practice. Here I have a plot of a parametric equation, set of parametric equations, moving along this path from t equals 0 to 1 to 2 to 3. These are the parametric equations that describe this path. So in order to get this into a y equals mx plus b form that describes this particular line, what we'll do is, first step is to solve for t. So if I add 1 to both sides here, I get t equals x plus 1. Okay. Now I can replace t with x plus 1 in this equation. So y equals 2 minus t, but instead of t, I'm going to put x plus 1. Now notice I put parentheses around here. I want to be really careful if I'm subtracting off t and I replace t with an expression that I use parentheses because I'm going to have to distribute this negative sign, and so really I get y equals 2 minus x minus 1, which gives me minus x plus 1. Okay, y equals minus x plus 1. This gives me a slope of negative 1, which appears to be what I have here, and a y-intercept of plus 1, which is also what I have here. Let's go ahead and look at a couple more examples. In this case, we have these two. Now, you can actually start with either one of these. You could start with the y equation or you could start with the x equation. A lot of times, one of these is going to be simpler than the other, and that's usually the one you want to start with. Make your life simple. Let's go ahead and solve this for t. This looks pretty easy. I'm just going to subtract 9 from both sides. So it appears that t equals x minus 9. Now I'm going to take this expression for t and replace this t with it. So we'll have y equals 33 minus 3 times t, which is x minus 9. So you notice that now I've completely gotten rid of t here. I've got y as a function of x, and it's really just a matter now of expanding this out and simplifying. So I'll distribute the negative 3 in here. Same thing here. This will be plus 27, and I should get y equals negative 3x plus 60. Okay, another example. Both of these have numbers multiplying t, so I don't know that one is necessarily easier than the other. Again, the x equation has smaller numbers anyway, so we'll start with that one. We'll subtract 5 from both sides first, and then we'll go ahead and divide by 3 so that we get x minus 5 divided by 3 equals t. Okay, now we're going to take this expression, which is equal to t, and plug it in here. So we get y equals 12 times x minus 5 over 3 plus 23. Okay, so again, this is a composite function. This is a function of a function. Now, how can we simplify this? Well, we have 12 times something divided by 3, which is the same as 12 divided by 3 times something. So let's go ahead and take the 12 divided by 3 and get rid of the fraction. We add the 23. And then finally we can distribute through here 4x minus 20 plus 23. And for our final answer we get y equals 4x plus 3. Here are a couple more sets of parametric equations, and these are a little bit more complicated because of the t squared. And I'm going to show you a couple of ways to do this one here. You can always go all the way solving for t equals something, but in some cases you notice we have t squared here and t squared here. And so possibly I could solve maybe this equation for t squared instead of t, because if I get t squared equals something, I can just pop that in right here. And so let's go ahead and try that. And so this equation looks to be a little bit simpler than this one, maybe a step or so, who knows. Let's just go ahead and try it with this. So we're going to go ahead and divide both sides by 2. We're going to get 1/2 y equals t squared, and we're pretty much done at that point. Notice now that I have an expression right here that's equal to t squared, equals to t squared. So x is really equal to 1/2 y minus 2. Okay, and the 1/2 y is the same as t squared. And so now I want to solve this for y. Let's go ahead and move the 2 over to this side by adding 2 to both sides. And then we can multiply both sides by 2 to clear this fraction. So we'll get 2x plus 4 on this side and just y on this side. And once again, we've eliminated the parameter. And in this case, you notice that even though we had two quadratic relationships here with respect to time, that the answer that we got for the pathway of y as a function of x is a straight line. And it's effectively because these two are acting the same in both the x and y direction, and so we really get the same thing. If we wanted to go ahead and do this a little bit more conventionally, if you will, let's go ahead and try this again. We'll completely solve for t, and then we'll go ahead and see how that relates to what we just ended up getting. So let's again go ahead and we'll use this equation here. We have 1/2 times y equals t squared. And so if we solve this, we're going to get t equals the square root of 1/2 times y. And I'm just going to leave it like this for now. Now we're going to set up x equals t squared minus 2. Well, t is this thing here, and that's square root of 1/2 times y. Well, what happens when you square a square root? Effectively, you get just what's inside. And once again, we'll move the x, or the 2 over with the x on this side, multiply both sides by 2, and we get the exact same result that we got before. Okay, this last one could be a little bit tricky because we have a t squared in one expression and not in the other. And so we still have two ways to do this. We can solve either one for t. This looks like it might be easier to solve. Let's go ahead and try that one. And we can go back and look at it the second way as well, just to compare. So we'll start with this one. Y equals 2t plus 7. I'm going to subtract 7 from both sides and then divide by 2. Okay, so now I have an expression for t, and then I'm going to plug that in down here. Now notice I'm going to have to be squaring this whole fraction here, so I'll have x equals 4 times y minus 7 divided by 2, and that whole thing squared. Now to square a fraction, we just square what's on top and we square what's on the bottom, and so x in this case will be 4 times y minus 7 squared over 4. 2 squared is 4. And the 4 here and the 4 here reduce down to 1. We get x equals y minus 7 squared. And now, rather than foiling this out and ending up with a quadratic expression, I think the easier thing to do is just take the square root of both sides. So let me put that in a different color here. Just take the square root of both sides, and you can see now that the square root and this square will give us just y minus 7 on this side. We'll still have square root of x here. What we want to do is solve for y in any case, so we can just add 7 to both sides, and we get square root of x plus 7. So this would be our regular y as a function of x type of a description for the path that that object takes. Okay, I'm going to go ahead and erase everything except for the final answer there. And let's try it again. And now instead, this time what we'll do is we will solve this equation first. X equals 4t squared. We'll divide both sides by 4. And then we'll take the square root. Okay, so once again, I'll do that in green. Take the square root of both sides, and that's going to give us t equals square root of x over 4. Now again, remember that if you have the square root of a fraction, we can think of that as the square root of the numerator divided by the square root of the denominator. And so we'll leave the square root with the x. Square root of 4 on the bottom here gives us 2. And so we have the expression now that t is equal to this. We will now plug that into this equation. Y equals 2 times square root of 2. I'm sorry, square root of y equals 2 times square root of x, that's better, over 2, plus 7. And again, the 2 out here and the 2 in the denominator reduce down to 1. We get y equals square root of x plus 7, which of course is exactly the same as what we got last time. And so let's just review the process quickly here. We are going to eliminate the parameter by first solving either equation for t. Start with either x or the y. Take the expression t equals whatever, the equals part, plug that in place of t in the other equation. And then finally, you're going to take that other equation and solve it so that we get y as a function of x. And we get the relationship between x and y without the parameter t involved.